And actually was just working on another circuit board recently. Where it went? Oh, it's this one. And I think I made a mistake. This is gonna, so I could start up and run that unit. But looked up here, and I had made a couple changes where I moved some things and changed it in program. But I noticed when I added the other components here, added all the other sockets and everything over to here, I didn't update the net connections, they call it, you know, basically relocated. Like this was a spare, but I made this coil, or originally was right here where I crossed it out. Well, guess what? Now it's still here, and that port wasn't working, and I had to move it over here. Well, I forgot to update this, so when I etched this board, it's got them in the wrong spots. Although it's pretty nice looking board there. Ready to go, boots up, you know, the LCD works. The one button doesn't work, and a couple other things because I moved a few things, and the program has been moved. So that board's trash. I'm like, dang, I gotta start over, and I'm cooking up just working in here, cooking up. Well, I got these 120 volt boards I made, that 120 volts AC, and it put, you know, I get my 300 volts DC to power the electronic motors that are in these 230 volt rated units I have. The motors are, you know, they're electronic motors, they're made for 230 volt input. Well, I figured a simple way to do that is I just do a voltage doubler circuit, which is you rectify one half the sine wave and then the other half, you know, steering the voltage with the diodes. You could basically, the other half will series this one with the next one, and then you get the same voltage on the secondary capacitor as you would with a 230 volt input. This only works if your end result is DC, but you're putting AC into it. So the perfected board is here, and it is high voltage. I gotta be careful, but I have a, oops, I just bumped this. So this potentiometer is my speed control for right now until it has another controller running it. But anyway, I manually have, I'll have to show it to you because the sun's going down, but the stepper motor board is going to be this. I put in my other chip back in the other one so I can just manually open the valve, and I'm like, fuck it, I'm just going to just manually move that stepper motor and get it close enough. And I'm just going to hang this board here, which is running this blower, and I have another board just like that out there running the outdoor fan. And right now I'm running 431, only got a little over a degree of subcooling. Almost could use a little bit of refrigerant, but usually want to hold off when you have a high load, because once your expansion valve closes off, it's going to stack up more in the outdoor coil. The outdoor coil is kind of oversized, I think, so probably good. Who knows? I have the expansion valve all the way up to 172 psi on the suction, but that's running at 12 degrees superheat. And the reason is it's freaking hot in here. It's probably 100 outside in the garage. I got the door shut. It's dropping it down, just starting to go below 90. And the air coming out was about 73 last time I looked. 70. So I have a 20 degree split. I'm standing at 90 degrees and it's blowing out 70. Let's go out to the outdoor unit before the sun goes down. And I just threw this door on finally. Oh yeah, it's hot out here in this garage. So it should actually cool down in that room. I don't know how well insulated that door is going to be, but the walls are insulated. It's not that big of a room. Now that inverter charger in there puts out a pretty good amount of heat when it does ramp up. This thing's cranking out the heat. I mean, it's just blasting me. And that's funny, my solar inverter charger is now running this compressor, the heat pump from a water heater. Eventually they're going to be 2-in-1. It's a goal, it's a whole goal. I just put a mini split in there. And then this one's running at the same time, which is a little bigger compressor. And it looks like this thing timed out on me. .8 amps, not bad. So here's my controller. I actually got this controller actually right here works. I was just, because I had to add jumpers, I was trying to make a new one when I relocated shit. So I could manually close the valve. Closing valve. And watch my suction will respond. Now it'll drop down the saturated point, or whatever you want to call it, the boiling point. See, but my superheat's going to shoot up. So the inlet part of the coil is now going to get even colder, but it's going to start coming back warmer to the compressor C73 out here. So let's open that expansion valve back up. Opening, I don't remember where it was, just 170. And this should start rising up again. And I jumped about 10, 15 counts. When it's in the loop, it's just going to go like one count every like 10 seconds or something. So it'll slowly adjust itself. This might actually be working good enough to stick all the thermistors on, but the sun's going down. I'll probably do that tomorrow. So now superheat's coming down. You see that's going up. So running it in manual mode, basically. Let's see what happened to my temperature inside. That's actually nice. Sometimes you actually do want to run just like it looks up. Sometimes you gotta find the equal. Let's close the valve a little bit. Let's go down to 66 there. Just gonna drop my suction again. Let's watch what this is supply air temp at the top, and this fucking phone man doesn't want to focus. It's pissing me off. I don't know what's with the YouTube app, but 69. Let me close it a little bit more. 166, go about 158 there. Suction pressure is 158. See suction's dropping. Superheat's gonna go up, of course. Not on the refrigeration screen to see the superheat and everything. You see the temperatures. The temperature of the suction line's going up because I'm starving it a little bit. It isn't really changing the supply air too much. It's just, well, it jumped up a tenth now. It will, because the inlet's going to be colder now of the coil, but the outlet leaving is cranking up. So 52.76, that's 24 degrees of superheat. And I had it down to 11. Yeah, right there. So I'm gonna bump this, open the valve a little bit again. Let's see, open. Oh, that's closing. Let's go back. What was it, like do about 170? I think it's about where it was. My step count. Suction's gonna start going up again. My suction line out here, which is, I'm measuring just right here, and the superheat will drop. Let's see if we can go from. It's alive. It's not running on its own. It's alive, running everything manually. So I got a fixed speed for the outdoor fan. A couple resistors shoved in that freaking board in there. I have that. I just showed in there. You have to see at the beginning. There's my 120 volt in and 300 volt DC out board I made. It's powering up the inverter board for the fan. And I just have some resistors in there just to stick it at a fixed speed. It's blasting pretty good. You see it's 105 or so out, and it's got 430 head pressure. Get back, dog. Don't even think. I'm freaking running away. Oh, my daughter thinks she's going somewhere. Which, she has a permit, so that means the wife is leaving too. Where does the whole thing?
Me and Mom are going to Starbucks.
To where?
Starbucks.
Starbucks is
I'm
shite.
paying for LED.
They're shite. They sponsored drag queens somewhere. They're being boycotted right now, by the way.
I do too.
No, you don't. Anyway, better not drop the political stuff. But Starbucks is on the shit list. I never liked it anyways for trendy weirdos. So, walking back, see the superheat's already down to 16. Supply air 68.6. Now that is going to keep dropping because my space temperature is going to keep dropping in there. Almost look better with the flash on. So 68 degree supply air with it. It's probably like 86 or 87 in there still. And it's stupid thing I wait for it to cover up, but it's still like 16 superheat. So I can open the valve just a pinch more. Suction's gonna drop it. So the cool thing, guys, is as far as refrigeration goes, it's working perfect, like perfect. What I just came up with off the top of my head is working perfectly. All it needs is just you know, the program to run it. So, like I said, this was a 1.5 ton outdoor unit. I split the outdoor coil into 2 circuits. Top half's going to be a winter time evaporator. Nothing should be moving through it right now. Nope.
So this EV valve I have wound all the way shut, and yeah, I don't feel any cooling going to the top coil, so it should be stopped. And then the bottom half is condenser all the time. And then this expansion valve here is going to the inside. The other thing to note is I don't have insulation on these lines out here. So I'm gaining heat on this, and it's insulated from here in. I just got to go to the store and get some insulation to do this and fix it up. I just threw it on just to start it up. They were back down 11 degrees superheat. 171 on the suction. Seems so high, people freak out because I go, well, how hot is it? Is it 100 in the room when you started it? Yes? Okay, that's normal. I had a guy call me, ask for some help earlier today, and he thought he might have a restriction here to change the expansion valve, and it's like 80 degree return, and he had 160 degree suction on our 410 3-ton, commercial package unit. And like, let's check your return air, because first let's see if there's more load on it than you think you have, because that's the kind of suction you're going to get with a high load. But I had to put the thermometer right at the coil, right at the air filters where the coil go in, packaging, and it was 80. I'm like, and then start looking more at and his superheat's like 5-6 degrees. The subcooling was also kind of, and he had factory charge in it. It was less than 10, but it was like pretty low, like, barely over 420, I think, 425, and it's like 110 where he's at, and 80 degree return air. I'm like, so I'm pretty sure his compressor got hurt, and lost some compression. So yeah, this thing's barreling out the heat, and we're running about 18 or so over ambient, because it's probably about 1. It was 105 when I looked a little bit ago, and if it is, then we're running 15 to 16 over ambient. Fortunately, that's pretty good pressure, especially with the load inside. So anyway, yeah, here's my electronic expansion valve. So we're down to 7.7 amps. Not bad. 115 volt rotary down in there, like a 10,000 BTU rotary. I took out of a LG emergency cooling unit. Let's check the messages there. What's the sear going to be? I don't know. The whole point is this. It'll be kick-ass sear when you think that I will be taking the hot gas, this system apart once this is done. Maybe in the wintertime we'll get it done, and I'm going to be taking the heat exchanger loop. I'm going to leave up on this platform, I think, and I'm just going to take the hot gas out of that and run a line up to the heat exchanger back down, and then so it'll go through this heat loop and then to its coil, and then the water pump inside will cycle with the temperature for the water heater. So in the summertime, it'll be, every time the water heater's on, it's going to be cooling that room. And then when the room needs to be cooled, it'll be heating the water until it hits a high limit. If I get all my controls the way I'm thinking I'm going to do, and then the high limit will just stop the circulator pump. And then all the hot gas will be, cooled by this coil out here. So not very much subcooling, but as I said earlier, you don't always want to dial in your subcooling too much if you have a high load and your expansion valve's way open, because you have more percentage of refrigerant in the coil inside than you will when everything's down to normal operating temperature. So this subcooling will actually stack back up a little bit. So let's see what the other messages are. Going to have to break out the measure quick to dial in sear rating. I think I measure quick in here. I just never gotten good at using it. Might be in my other phone, the one I'm recording with. No, is it MQ? Is it this? MQ HVAC? Yeah. This is running off grid right now. This outlet here goes inside to my solar charge inverter. So right now, those lithium batteries, remember I had that lead acid batteries? I just pulled them out of the way, by the way. The lithium batteries are running this rotary and this rotary at the same time, and my lighting and everything else pretty much in that room. So let's go in that room and see well, let me see what the supply air is down to. 68. It's slowly getting there. But after a while, to get that, like I said, I'm gonna have to keep modulating the suction down, because like right now the coldest point the coil will be was 59, but we're running at, looks like 10 degrees superheat now, and that's measured way out here. So I probably can afford to drop my let's close that valve just a little bit. So we're at 175, go to 172, suction starting to drop a little bit, which will drop my temperature going into the coil. Hope you guys can hear me okay with all the racket that both the Lennox bastard and the Goodman, actually Lennox Frankenstein, you can't hear right now over this bastard. Go, bah, bah. It's the Goodman unit. Hopefully you can hear me over that shite. So there's 4 compressors running at my house right now. 1, 2, 3, 4. These 2 are running off of energy that the sun stored up earlier. Okay, so now the superheat just went up a pinch from me closing down the metering device just a little bit. But 13 degrees here, could be 10 in at the coil for all we know. Let's see if the, still 68. Still 68 degrees, so, you know, sometimes lowering the, pinching off the expansion valve just a pinch will help the air temp, but sometimes it doesn't. But you do have to keep closing it off as the load goes down and the superheat starts dropping, you know, and then you keep dropping the suction, pinching it off, I shouldn't say dropping the suction, pinching off the feed, you know. Suction just follows it. So 165, just a really good load in there. But yeah, this thing's cool, and I could switch this right now without fucking anything up. I think it'll go to winter mode. Oh, and oh yeah, that clicked because I just changed something. But see this stepper motor right here? I should be able to move it now. No, something's clicking. Oh, just I'm in one other mode. Hold on. All right, there we go. See, it's moving. So when I do this, that's what the stepper motor inside this unit is doing. The other one. Eventually, this dome will be on the other one over there for the winter one. So let's go back to summer. I do have a PCM output on this cable. I could have plugged it in to run the fan motor, but I just have it fixed right now. Get back to where it was. 189. Ooh. Oh, that's going to be thrown off now because I just changed the count. While on the other one, and I'm using the same count, so I need to go back. What was it? 172? Oops. Ah, shit. Because remember, it zeros when it homes. Ah, come on. I'm pushing the button too many times. Winter. Oh, I did change it. I'm losing my mind. What did I say? 172 or something? It didn't move my stepper. It's just that the value changed because I toggled which stepper I was controlling. So I just wanted to keep count there. 12 degrees. So let me close that just a pinch more. Let's go down to 70. See, the suction immediately started dropping a pinch. And then the suction line's going to probably toss up just a little bit. 67.8 inside. So we're getting down there. So the room's cooling real slowly. I didn't have enough batteries. I had to scrounge and take batteries out of a mouse and another controller and everything just to power up all my testos. And or I'd have a return and supply, you know, hooked up. I just have a supply hooked up and then a regular little stick thermometer laying down on the table in there. And it was running 20 degrees discharge temp, you know, 20 degrees cooler than the space temp. And this thing here is just, I wish I had another thermometer out here. It's, you know, it's like probably in the 120s coming out of the front of this bastard. And as soon as I started getting the charge added, I'm like, yeah. And it could be a pinch low still. I just don't want to overcharge it. But it might cool actually just a pinch better if I put it, if it is flashing a little bit. So I have that open. Let me just pulse this tank a few times. Subcooling, still kind of down there. I got to go to Lowe's and get some insulation and wrap that. I think it's all insulated inside. There might be a piece of the quarter inch that isn't. It's gonna start fucking dripping in there maybe, but it'll cool better, I'm sure, when I wrap all this. Because I mean, this is all in 105 degree heat out here. That's cool. So look at that. 10 degrees superheated. Actually might have dropped a pinch. Yeah, pumping it in. Sometimes if you put this in the wrong spot, you'll influence your thermometer from adding charge, but it doesn't look like it actually dropped just a pinch. I'll go ahead and close the valve a couple more smidges. 68. But there's a thermistor that's on the coil in there. I gotta run it out to this. Close it a pinch more. Oh. Now, so if I push and hold that, I mean, it moves like 4 counts before you can even blink. So, like I said, it'll do 1 count like every 10 seconds or so when it's trying to adjust. So, you know, it'll catch itself. I might actually get this with a 68 still. Suction dropping a pinch more. Every time I change screens, that stupid pop-up comes on. 10 degrees, still 10 degrees. It's actually dropping down with it. So that little last shot of refrigerant might have actually helped. 60 steps. Suction dropping the inlet temperature a little bit more. Superheat's not climbing like it was early when I closed it. And there it goes. It's actually kind of leveled off right there. That's expected if you start closing the expansion valve too much. I have a dead band, so I think once it goes like I think my default program I made when I actually start, it's gonna like if it goes above 12 degrees, it'll start dropping it. Well, my AC just kicked up the second stage. I bet it's 7 o'clock. No, it's 8. Thought it was following schedule. Anyway, check the inlet temperature now. 66.8. I think it actually dropped a little bit, didn't it? So we're actually starting to get some nicer supply air. This supply air was 80 when I first started this thing up about 30-40 minutes ago. And the room was 100. So I'll bet you that room's like 86 now or something. So this thing will actually, this is the peak of the right after the sun went down, man. But when everything was really hot, so I have no doubt that this thing won't hold temperature. Let's see, that was 66. 10 degrees superheat. It's actually pretty low. My throttle's down a pitch more. See, I'm manually doing right now what my microprocessor is going to do, and that is, as the load drops, it's going to keep dropping the metering device. See right there, suction start to drop. Temperature going into the coil start to drop. Superheat popped up a couple tenths. Now it's kind of leveling off. You guys hear me okay? Hopefully through this shit. Sounded good. Seeing it live, so this is cool in itself. And I thought of something else, but I don't know, I probably shouldn't do it, but old main baseboard for a carrier unit probably just has a bad relay on it or something. I was almost thinking of getting a software dumped into it for like a real basic package unit where it doesn't have all that many, like it doesn't expect, you know, in the configuration take out like no expansion boards, none of that, so it won't freak out when it doesn't communicate. You know, take out all the frills, just have the normal pressure switches. You know, I don't have a pressure transducer. I think you could take that out in the configuration and turn off so it doesn't expect it, because I mean some of those can be programmed to where it looks for your suction pressure to drop, and if it doesn't, it thinks it's 3-phase reversal, stop your unit. I know you could turn that off actually, but maybe I could get it to where it doesn't have any alarms. I have another Comfort Link, whatever, scrolling marquee, 2 of them. My brother-in-law gave me sitting in there. He said I can have one if I fix the other one for him. So I got to put some tactile buttons in there to make it awesome. So I thought it'd be kind of funny to program one of those, or use what's in those generally, but get it close enough to where it would run like, you know, my system. That'd be funny as hell. But I made this, and it's gonna work. Oops, superheat's down to 9.6. Let's throttle that down a little more. Let's go down 154. Steps. Suction can keep dropping. What was my suction when I started this? I started a live stream. I think it was a good 180 or something. It might have been higher. It was pushing 200 before I went live stream. Let's look at the supply air temp. 65, dude. And hopefully this phone, I was just thinking this phone hopefully doesn't overheat. It's probably gonna have the flash on. Probably gonna stop our stream. Let me go inside for a few minutes. I was just thinking about that. Checking the temperature in there. 10 degrees. Let's go ahead and close this down a little bit more. Might over drop it, but I have the weird feeling that standing at 100 degrees, it's probably 100 with the sun down right now. I have a feeling that the phone, the Samsung in all its glory, is going to stop. And especially when you use, I had the flash on too, which I felt the heat on the phone. Dude, it should be the nicest it's been in here in a while. Oh yeah. Look, it's down to 82.7. So however long this video's been going, that was 90 when I started this stream. Does it say how long it's been going? Somebody say in the comments. Of course you won't know because it doesn't, it just shows live, huh? Unless you rewind the playhead, but yeah, it's a 10 superheat. So now you can see my pressure is starting to get down a little more normal. Saws air and heating service. You were late. He's usually the first one in here. So 64.8, and it's like 84. So got like 19 split according from there to there. Could be even warmer where it's dropping off the ceiling. I don't know. So manually be controlled in the expansion valve. So 430 over 159. And this is the board I showed at the beginning. 120 volts is going in with this plug. Two diodes. The first diode, shit, paper's down. But it's this. You it will flow current on the positive, with this being positive here, I guess, or the other way around. When this goes positive, it charges a cap, and this is negative. And then when it switches around where this is positive, then this capacitor is in series with this diode to charge. It takes it plus the next positive sine wave that's going the other way, or the other, I guess it'd be negative. I don't know. The next half of the sine wave goes through the diode across the capacitor to charge it. And it's basically, it puts this in series with this one. So plus, so this would be plus, minus, plus. Plus goes through plus here, and this would be minus. So it's minus on top, plus down here. The inverse one that charges this capacitor first, because this plus will go through this diode this way, charges this as plus. Their schematic was wrong. I had to kind of draw it, change it. So it goes, charges this plus, when this is plus, and then when it switches phase, and then this is plus, then it's basically like, 120 volts in whatever you charge this in series. It's actually 170 volt peak to peak is what 120 volt AC is. It's one, so DC, if you look at it, peak to peak is 170. So it's 170, almost 170. So it makes like 330 something volts across this capacitor every other half wave. And so that's what you actually work with, depending on how much it actually drops, from sag. So it must be kind of humid because it doesn't feel like crisp in here. But 83.6 degrees is what the room is. Just since I started this video, it was like 90 something. It was 100 when I first started that unit, and then I didn't have it running too long. I got it kind of balanced enough to take off and go upstairs and go get this phone here to stream. Well, this one's connected. So yeah, that's pretty cool. And then this stuff, I'm sure this thing here is kicking out the heat. Actually, usually feels like an inferno. And this thing's running 2 compressors right now. It did drop down to 51 volts. It's never dropped that low in a while. But somebody already used the water heater, so it's getting ready to kick off, I should say. Using almost 2 kilowatts. 1.96. This light here is like 100 watts of it. It's 1.86. 1.96. Yeah. And right now I just have a potentiometer to adjust the fan speed on that. I took out, it's up there, but I took out the control board, which is good, which is in there. This is my coil temperature sensor. I'm just going to make an extender plug, run that cable out the wall and out to my controller out there. So it's going to look at this coil temperature and then the suction, and it will just
try to keep the superheat between 10 and 12 degrees. That's like the dead band, I think. And if I have to change that, I'll change that. But I think that's a good number. But yeah, this is cool. So this thing's doing what that paper says. It's charging this capacitor, and then every other half cycle it's series with the incoming voltage and charges the second one, which is a small one there, but there's, you know, one inside that too. Probably not much. Actually, there probably isn't. I was doing that when I was controlling the inverter whole boards. But for this little motor, I think that capacitor is enough. It almost needs to be a bigger one. I got another big one right here, bigger one. For these voltages, these are small compared to all those freaking big monsters on all those VFD boards. So I don't know if I have enough room on that one, but it seems to be fine. I can crank this fan up. But that's way faster than probably ever ran on its program. And remember, that compressor's on like 10,000 BTUs, I think. That might put a little more load on it. Actually, it's doing pretty good. I got it probably back to about where it was. It's blowing pretty good. Gotta hold that up. It's waxed in it. But there's another little circuit I made. But that board I screwed up on the design. So it's out there on the freaking CNC. But I started showing in the video why I said screw it and I wired it the way it is right now. Is that board that's out there right now, I had to move some things because sometimes you'll hook things up and it's like, this is an input and it's a bidirectional input, so is this. But sometimes with all the hardware you use inside, the combination of it, you can't use everything the way that you think you can. Like it'll like an input just don't work, or an output will just stay high all the time. I'm like, what the heck, no matter what I do in the software and the programming. So sometimes I have to switch things around. Sometimes it's swapping an input with an output, remapping them, and it works, things like that. So I got rid of this port A3 and went and moved my coil over to A2, and it worked. And I moved a couple things, and then I forgot to, when I redid this, I just basically took the same one, my last saved, design in the computer, and just added these other outputs. There's the compressor, there's the outdoor fan motor header, and then I added this 24 volts AC goes in through a resistor, through a diode, capacitor, filter it in a steady DC state. It's going to power, this will power this optical isolator, which is then switched 5 volts logic through a high pressure switch and everything. See how I did that? And then it's going to tell this when to run. Well, I forgot to move this over, and I think one other thing. And so, as good as this board came out, all beautiful and whatnot, I added all the extra plugs. I'm like, yeah! It says Frankenstein AC on it. It's got a bunch of filth on it. Anyway, fucked up. Because coil is back over here. I needed it in the software. Since my laptop's starting up and shut down. The software, I need to just take this and switch them. And I didn't. And then so when I made the circuit board layout, it connected the thing back over here, which doesn't work, and my program got switched to over there, so it wasn't reading some of the sensors or switching things right. And I realized it after I did hours to build this board. 4 passes, and it made nice deep grooves, good isolation, one of the best boards I've had. Some of them come out okay, but anyway, shit. So anyway, it's 82 degrees in here. I'm just gonna let that sucker crank. It is sucking down my batteries, running 2 ACs at once, 50.8, but that's about to stop from someone using the water heater, and this will get down to temperature here in a little bit, and then it only, well, I would say it would cycle if I had a thermostat on it. It's hot. It's like 100 right here in the garage. There's a cabinet for that thing. So it would cycle once I get the thermostat down, but tonight I'll just let it run a while, and then I'll come out here and turn it off. I'm gonna have to either unhook this, probably unhook it, because barricade it with all this shit, because that fucking dog, sorry, but that dog, I know
if I'm surprised he hasn't come out here already. It's still a puppy, that big old black dog, and it's gonna tear it up. Let's see what we got on the messages. 25 minutes ago, so it's probably been what, 35 minutes since he texted me that. So that's pretty good performance. Let's close that valve a little bit more. 149. Put a 145. Suction starting to drop a little bit more. Check the comments now. So I just got the he's live 25 minutes later. Yeah, so it's the Frankenstein, just for those that didn't start, is I'm running it manually, so it's not ready, but I went ahead and hooked the lines up this afternoon after work, evacuated it, dumped some juice into it, and running it. I got the fixed speed inside, just with that board I showed you guys, and the potentiometer for now, and then I just have this hooked up. I just dropped my other chip in here. That's the first one I had for testing, where I manually switch the values. So I'm manually running the stepper motor boards, which are working. You guys can see that there's no problem with that valve holding. It's not hot in the slightest, which means I have the current value set good on there and everything. Let's go back to the comments. What kind of voltages are you putting to the motor? All right, well, the compressor is not an inverter compressor. I took it out. This was a bad unit, got for free. So the compressor is a straight capacitor right there, start 120 volt, 10,000 BTU rotary. I think it was 10,000 BTU. And then the outdoor fan motor and the indoor unit, they are at 230 volt, and that's why I had to make those boards I made. There's an identical board here and the one inside. AC voltage just goes in, and I have a voltage doubler circuit, so instead of 170 volts DC, which is what you get rectified from 120 volts AC, I have a 300 volts DC rectified. Steps it up, and when I ramp the fan up, it does drop a little, but it's fine. So and I have one of those boards for the indoor fan and for the outdoor fan. Let's see. How did you make the blower work without the factory board? Oh, I think I kind of just said that. So the indoor motor has the inverter board built in. So you need to put high voltage 300 volts DC into those, and then you also have to put 15 volt DC control voltage. I didn't show that inside, but I have a little wall wart, 12 volt wall wart. It was pushing 15 volts unloaded, so it's putting close to 15 volts in there, exactly what it needs. And then that same voltage you also divide down to send into the fan speed signal, and that's how it tells it what speed to go. You could also find these units that have these motors just like that out there where everything's into them, but this one doesn't. This one needs the inverter board. The big inverter board, I can't use it, so I have an inverter board from one of those tall units in here, and then it basically is like a two-part, it's like having the inverter parts separate, like on an ECM if you separated it, that's all it is. It has the same 5-wire scheme going into it, so it's the same exact scheme, so that's why I made two identical boards. And I have resistors jammed in right here just to get a fixed speed, but eventually I have PCM right there with the optical isolator, which I already tested and worked. I have the cable for it right here, and I even have the program in there. I could plug that in and run that motor whatever speed I want, but it's just easy to do what I'm doing right now. Let's see. Yeah, I like this kind of stuff. So like whenever I worked on this kind of stuff, different brands, and I've noticed that most of them operate similar. Mitsubishi, Carrier, LG. I think there's a couple parent companies like Modine or whatever, isn't it, that makes these, I think? If I'm saying that right. So 152, I'm starting to get into a more normal suction, so let's go ahead and superheats down a little bit. So let's go ahead and drop that valve a couple more counts. So like I said, my controller, as how I have it programmed, will probably run it between 10 and 12 degrees superheat. Or probably even better. This is ice cold now, which of course it is. 63 degrees measured right there. Probably even colder up here. But I have like 6 feet. You know, it's all uninsulated. It's pretty cold. Yeah, 63 feels pretty cold. It's 10. Let's see what the inside air is. 61.9. 61.8. So
discharge air is dropping with the room temperature, and I'm sure it's got to remove a bunch of humidity. Oh, and by the way, the freaking condensate's just open in the room in there, so I might have to drop a tube down into a bucket if I keep it running. I'll just keep an eye on it. So 10 degrees. Once it starts going below 10, my program, like right now, would start bumping it up. So I'll bump it down another count. Boop, shot it. It's going to drop the suction, shoot the superheat value back up just a pinch. Now, we're seeing instant superheat changes because it's a calculation of the pressure, which makes this temperature here. I'm going to drop it down. So actually, it's like the room started to probably dry out a little bit and drop down, so I can actually start throttling down the expansion valve. So your coil inlet temperature, or a couple rows in, is what it's going to really be reading. Is close to what this always is. I mean, it is what it is. I mean, your first bit of feeding into a coil is based on what the pressure is. So whether you're looking at a pressure or measuring temperature, they're going to pretty much jive. And then you're just looking at superheat out here at the compressor. So if it drops less than 10 degrees, my program, when it's running the program, is going to start closing the valve down until it's within that. If it goes above 12 degrees, then it starts opening the valve until it corrects. So it's going to keep it between those 2 points. See, it's throttling down more and more. 150. So I'm starting to get into the more happy realm of, what you won't like to see. But usually you start, you got an 80 degree at the most, space, you're running 150 or a little below on your suction. This room started at 100, so I started at 200 psi. It was about 180 something, close to 190 when you guys chimed in. Indoor 61.5 for discharge air temperature. God, I mean, we didn't have this freaking testo stuff in the early days, man. We didn't even really have. Our superheat was beer can cold. Now you see my subcooling hasn't really took off like I didn't want it to, but if you don't have enough outdoor coil, you add a lot of refrigerant to get your superheat to start getting a decent amount of subcooling while your indoor coil is flooded. Then when your TXV or EXV starts closing, then you'll have an overcharged outdoor coil. So I'm starting to get more into the normal range, and it hasn't shot up, so I can almost add a pinch more refrigerant. Pulse it a couple of times in there. And this coil is probably, I guess, a pretty decent size, using half of this coil for the condenser. And we don't want too much early flashing, or we're going to lose a little bit of performance. So I know it needs to add refrigerant sometimes. I just don't want it to. I just don't want to overcharge it. Balance back out after adding a little bit of refrigerant. Throttle this down a pinch. 139 counts, go to 135. Suctions to start dropping again. That went up to 62. I thought that was on top. It switched around, but go ahead and close this down some more. The phone hasn't shut off on temperature yet. I was just looking at the last comment. I don't know if that was to me or to somebody else in the chat, but yeah. So half wave. I mean, regardless, you always get the same peak to peak, I guess. I don't know, but the way they go through the rectifiers, but basically this is half waving twice
half waving through a capacitor and then half waving in series with the capacitor, and then I get double the voltage on the second capacitor as you would if you just rectified it to the first one. So yeah, if I stick my voltmeter in on the output of that board, it's close to 300 volts DC with just 120 volts speeding it. So I didn't need a buck boost or any of that stuff. I did that on a vane axial fan for a carrier. It worked. I had like just a bunch of jumper wires when I first was trying it, and it ran. That freaking motor took off. Close that a little bit more. I had the suction almost down to 150, but when I added just a pinch more refrigerant, it kind of shot up just a pinch and stayed up. Trying to get the superheat between 10 and 12. Keep closing this down just a pinch more. Boy, that's way down, man. It wasn't long ago that was 170 steps on the stepper motor. So I just closed it down a little bit more. So now it's starting to correct, getting 10 degrees. Still about 62. Seems like it wasn't that down to like 61 at one point. So that's kind of crazy. They're starting to drop down a little bit. And like I was saying, just like with refrigeration, sometimes if your expansion valve it stalls out, doesn't keep closing, you'll stall out on how cold the air can get. And the coil will just kind of sit there. So you almost have to like keep closing it at some point. So I'm closing it a little bit more and more right now as the load's dropping in there. Drop a little more, man. I've dropped that down quite a bit. 114. Still slowly correcting. Superheat's still dropping on a little bit. Those are quite a few more jumps right there. Flame's getting down. It's still like 63. Just that the suction went shot up so much for some reason. Hopefully someone didn't go in that room and open the door. That might have happened. Somebody might be snooping in there. 62, which would throw everything off. I'm sure my daughter didn't go in there or something. It might have just changed because door shut. Might have just changed because I shot some juice into it. Kind of funny because I had to open that stepper quite a bit, you know, when I first started this sucker up with it that hot. It's getting down into the 61 knockpower it was. It's also probably got the humidity and everything in there. I gotta figure out how I'm gonna do the drain. I could just run that into a bucket and drain the bucket. Now, subcooling actually bounced up a little higher. See that? When you can start throttling down the refrigerant flow through the indoor coil, you're going to start stacking up a little more. And indeed it is. So that's why you don't want to go too carried away. You don't want to go, when it's hot, and just add refrigerant until you get 10 degrees subcooling. That will bite you in the ass. Especially if you have microchannel coil, you will screw yourself. Yeah, see the subcooling bounced up a little bit. You don't need a whole lot of subcooling on these anyway because there is no liquid line. It's starting to, it's starting to flash right there, which I need to add the insulation on. So I'm losing a little bit of performance, I'm sure, out here. As it's sucking air across bare copper, Close this down right now. I got it. The temperature in the coil will start dropping even more. Choose the coldest point right now.
once that room starts getting about 80ish or so, you're going to want to start getting a little further. Yep, so there we go, back up a little above 10 degrees superheat. So it's about target. See if the discharge air temp is getting better. Oh yeah, 60.9, so it dropped like a degree within a minute or so. So pretty close to 20 degrees. I have the fan cranked pretty good in there. That's a 1-ton head, but the compressor's not a full 1 ton. So I don't know what the performance is. Reset my amp meter here. Still about 7.8, 7.9, so that hasn't really dropped. Superheat's like pretty good still. It's starting to drop down a little bit, so I could probably clamp this down once it gets below 10, because that's what my microprocessor will do. Keep it optimal. I could have just found a 1-ton expansion valve and just ran liquid all the way in there and stuck the damn valve in there, but that'd really be hacking a mini split. 60.4, 60.3. Supply air's starting to get into that nice, useful range. Alright, so dropping below 10. Close the expansion valve, a couple more steps. Suction should start tracking along with that. Seems like I've had to move the stepper a little more and more as I get to this lower range. Kind of interesting. Acceleration through that bottom of the V channel. Who knows? Maybe it's... Oh, there goes. CVD came up a little bit. It might change. It seems like when it was more open, it was like this, when the suction pressure was really high. Just moving every count or two was distinguishable on the pressure gauge. So it did just adjust right there, though. And as you come down and as you get the room down, the supply air is going to get better. There it is, 60 degrees. We're going to be in the 50s here pretty soon. So just remember, guys, in case this video quits, when we started the stream, the supply air was over 80 degrees. It was like 80, it was 82, and it was like 100, and then I was starting to get into the 70s, and then I was getting down to the 60s. Maybe it was like 68, 70 when you guys chimed in. 68, 28, around 70, and it was like 90 in there. I can't remember. It wasn't too long before I ran in and thought I should record. Superheat, go over 10, let's close it just a pinch more. Go down to 80 steps. And the resolution is 0 to 255 on these stepper motors from open to close. So 125 would be midway, it's like 80. In my program, what it will do is, and this is what, I know this is what Bond beacons and stuff did, so I learned about this a long time ago from reading their manuals and 20 years ago, but whenever the unit cycles off, you remember your stepper motor position, and then I'll close the stepper motor. I'm always going to overclose it probably just to like make sure it's always zeroed, it's always home. So basically it'll always run more steps than it takes to close it, and make sure it's homed, closed. That way it's an accurate count when it opens, and then it's going to open where it left off. And that's what I believe pretty much most controllers do, which only makes sense. Close a little more, just drop down 5 steps. Like I'm starting to really get down in there and drop in the range. So suction's down to 147. The coil temperature is going to start below that 50 coming in and 60 coming out. Now we're going to start getting good supply air temperatures in there. So we're getting nice. Oh yeah, 59 degrees. Everything is textbook, I have to say. This shit, there's a lot that could go wrong, but it's just like, this is just like, just from experience, blind experience of just putting everything together, just not much thought to it. It's just, I know that's like a 1-ton valve because, maybe even a little more on this one, but the other one I have, just because that's what was in the 4-port system, the head. I just knew it's going to be, that's about right. I knew about what BTUs are going to be when I combine the circuits that I wanted to use for the bottom half. So only the bottom half of this coil is condenser. The top half's an evaporator. So when this is heating my water, when I have the hot gas and it's cold in the winter, I don't want to freeze me out in my electronics room. I'm going to switch this to winter mode, and it's going to just shut down this expansion valve so it won't flow to the high wall, and instead it'll
flow to the top half of the outdoor coil. So the top half of my outdoor coil is an evaporator now. Stepper motor right here, I just have the head off and it feeds right here. And I repurposed it. So the top half, it's suction. So you got, this is suction from the inside line, all nice and sweaty, going back to the compressor. It tees, and then this is suction to the top half of this outdoor coil. So when it's running in winter mode, hot gas will go through the heat and the water, then in series it'll go through the condenser, and then it'll go through that expansion valve, and the top half of this coil will be the evaporator. So this outdoor unit will be a condenser and an evaporator in the winter. Most of the heat will be rejected through the water. 141, right about 10 degrees. 58.7. So that room is going to start getting nice. Within an hour, that room will be crisp. Crisp. Yeah. I should have, wish I could have done this earlier, because that room has just been miserable, and I've been working in that room. Now, my CNC is outside of that room, and now that I just, did that. And for some reason, this Frederick unit didn't want to start properly the last couple of times, and I've turned it off and on a few times. Got an alarm in it for some reason. But my bastard's been this sucker's been kicking ass actually, but it only cools right in that one spot. It doesn't cool the garage. There's no hope to cool the hottest garage. They insulate those freaking walls, man. And so right now, if I were not to be modulating this expansion valve, say I just put it in a fixed position and walked away, this thing would be flooding right now, and it would never cool. The room would stall. It would not keep cooling. So now you see my superheat bouncing actually up and down about 10. Once that gets below 9, though, I like to flamp it down a little bit. But yeah, it's kind of bouncing around. .2 on the suction temp, supply air temp. Look at that, subcooling is 11. See that, guys? See that? That's what happens. Let this be a lesson, man. It takes a while to figure this out, that it happens, and I've seen so many people overcharge units, but they start up a unit, installer, start up condensers, split systems, when it's hot in the space, hot and humid, and that freaking TXV is throttled way open. So they just gas it until they get 10 degrees subcooling, because it's feeding so much refrigerant in that indoor coil. But then once that temperature comes down, the expansion valve throttles down, it stacks up refrigerant. Next thing you know, you got 20, 25 degrees subcooling. Look at that, I got over 10 now. And it was 4 the last time I added a pinch of refrigerant to this thing. And it's actually a little higher discharge pressure than it was 15 minutes ago. See that? It's kind of bouncing around a little bit. And I don't have the high side hooked up. I do have a high side port though, it's right here. Liquid line. I added a bunch of ports to it, which you don't get. But 11 degrees ain't horrible. But just goes to show you that your subcooling will really drastically change once you bring down a space to the normal temperatures. I don't know how much longer I need to do the video, but I think we pretty much see that it worked, and we're almost to normal operating range now. That room is probably about 80-ish, or maybe even 78 or something. We'll go in there, maybe look here in a second. 57.8, man. Let's go in there and see what the, it seems to be stabilizing on the superheat right now, so maybe I'll just close it 1 or 2 more counts. Put that on, what, 3 counts? It's going to drop down probably below 140 maybe. That depends. So sometimes you, like, if I open the feed, it'll raise the temperature of feeding the coil, and the superheat does come down, but it also, sometimes the coil temperature doesn't come down, and it might even go up a degree or so overall, average temperature through the coil, and then the supply air will go up. Like I'm saying, it'll stall, just like if low temp, if somebody adjusts one when they're hot, and doesn't stick around for the box to drop down, and the TXV doesn't clamp down enough, it'll like it'll stall. It won't like cool. You gotta adjust them. Sometimes you need to. It'll bring up the superheat at the sake of dropping the coil temperature, or the average or whatever, a little bit. So it's going in at 48, coming out at 60-ish. Might have overshot at one little point there, but See, 57.6 coming out. So it's the coldest yet. So I think that's gonna hold the adjustment for, look at that, 139 on the suction. Remember, it started up at 200 psi, and that was at 10 degrees superheat. Shows you how warm that room was. Turn this flash off. Light off for the phone overheats. So, hate opening this door. Now that's cold. Now it's gonna be a wave of freaking 100-degree air coming in. Oh, this shut off, bastard. 77 in here. So 77, 57 pretty much. I mean, so it's been like a 20-degree split across the board, you know, from the when it was like 100 when I started it, and down to 90. Now we're down to 77 in here. And that's actually jumping up probably 10. That's going up and down because I opened that damn door. But it's like, it's kind of weird because it's the coolest it's been in here, but yet it doesn't feel like cool to me. But of course, I'm sweating from working. 57.7. So it's pretty much 20 degrees from less than what the room is. And who knows? I mean, I don't know if overspeeding the fan and then opening expansion valve would do any good. Probably not. Here's this. Put it just so if water drops, it doesn't go right into that or anything. Might not be quite humid enough to really notice anything. It's Arizona. With that subcooling 11, almost 12. So plenty of refrigerant in there now. Yep, so this is my first test board, and I had to keep soldering and unsoldering things to make my little step-up board. But, so the way this works is, like I said, diode charges this one, and then the next wave puts this in through this diode, puts the next capacitor in series with the other half of the wave, and then you double the voltage here, and then you have the high voltage out, and then I got my working voltage, 15 volts, and then this is an optical isolator, so I just pulse it with my pulse width modulation, and it sends the voltage back. I'm actually missing the capacitor I should have on there. And it doesn't really need it because it's inside the motor anyway, but you pulse that and it will adjust the speed. But right now I'm just using a potentiometer. Carefully all soldering with wires. So. Yeah. I bet you, the water heater stopped at least. Oh yeah, my battery voltage is down to 50. I haven't seen it get down really that low in a while. It's usually about that low in the morning. So I might actually run these batteries down now, running this thing. But you know what? This thing's ran the most. It ran probably an hour now, continuously. Where once I have it all up on the thermostat, the room's gonna be cooling off all day long on solar power directly, and the battery be topped off, and then it'll just be cycling to maintain the room after that. I need to put a weather strip right here now that I got this door. I kind of had to keep cutting the door down. I had to get this freaking button latch thing to work. It's pretty cool though, the way this door did work out. Pretty close tolerances. So I'm gonna get some weather stripping and just put it right there. And this side's pretty tight actually. But I need to put something up here probably. I don't feel a bunch. I do feel some heat right there, so some's infiltrating. Actually, I need to, I gotta have some fresh air in here. So I was gonna my idea was to bring something in and just maybe a piece of ABS or something, cut another round hole and just go and turn down right on top of this so it draws in some outside air and conditions it just a little bit so I don't die of CO2 poisoning. So 140. So you can see that's pretty normal pressures now, and it'll get better as 57.7. So, and it might actually stall right here for a while because you got to think now that it's kind of cooled off the air, all these walls got to cool. Walls, everything. At least the good news about the tower breaking is that tower, that old 1055 AMD from 11 years ago, felt like a space heater coming out of its water-cooled radiator. And now this laptop, somebody asked me in the comments yesterday, where said, you should have just built another tower. I said, well, since I had to invest the money in one or the other, I chose the laptop idea.
because $800 gets you a Ryzen 5. I bought the little dock, so I'm running 2 monitors on it. This puts out less heat, way less heat, and it's because it's a laptop, it's made to be efficient, and it's probably only going to pull 100 watts max, not 400 watts max and 300 watts idle, which would be drawing on this. So this thing was pulling 2 kilowatts to run the heat pump for the water heater and this AC earlier. Now I'm down to 1.16. So if I turn on my light, it'll be 1.06 probably. Give that a second. Yep, 1.06. This light pulls 100 watts. It's pretty bright LED. And honestly, when the monitors are on, I can almost turn off that light. So let's see what that goes up to. Was it 1.16? Let's wake up the laptop. So we got the wireless hooked to it. Oh my god, I did a cool thing too. Because I can use a 10 key and label it for a shortcut to run my CNC to home it and everything. I found a little Bluetooth 10 key just to show you guys that. Alright, so this is on 1.28. Was it 1.2? So it's like 20 watts it added to turn on those monitors. Is that right? 1.26, 20, 30 watts for both monitors and that computer monitor? That's pretty surprising. And if I turn this off, 1.18, 1.17, 1.16. So 100 watts for that. But I mean, if I'm just watching videos, I don't need that light on. In fact, I was doing coding and stuff the other day with the light off. So, yeah, now that's blowing on me. So at least it's blowing like 50 something out. It doesn't feel cold to me, but I think it's just because I hustled. I did a lot of work in the last 2 hours. Huh. But yeah, so it's pretty cool. 57.6. So it'll probably sit there. You can see I probably don't need to go chase the superheat much anymore. Maybe by tomorrow I'll hook that circuit board up. Oh, look, start talking and now it freaking dropped below 10. So I could probably go down there and bump it down. That's crazy. And that'll drop my temperature down. But like I said, sometimes if you don't drop it, that's the coldest your coil will be. So even though your superheat's dropping, your supply air doesn't necessarily, it'll stall. It won't keep cooling better. You gotta get the boiling point or whatever you want to say, down a little bit. Now, of course, if you add too much superheat, you will lose performance that way, and that will cost you but I don't know, it's kind of weird, interesting. The superheat just dropped way low all of a sudden. It's down to like 6. So, I jinxed myself because I told you guys, hey, I was just going to say it. I'm gonna be able to just walk away and let it run like that for a while, but now, superheat's gone. So you don't want it to necessarily flood the compressor. It's not like, there's only those little tiny built-in accumulators on these things, See, it's all nice and sweaty. 72 count. Let's go down about 67. Should get down to 130 for the suction. Still cranking out the heat. My goodness, it's hot. It's working. Like I said, it seems like I have to be. Oh, there it goes. Just give me a second. See, my super is pretty low. Start taking it down, using my supplier, and you can fiddle around with it. You'll start to see where the supplier will change. Now, of course, it also matters if you use a thermometer, because one side of the coil might be the inlet, and one part of the thermometer might be the outlet. It's not always like a perfect average temp. But now it's back up to 10. Let's see, we're down to 137. We were up a little over 140 a minute ago. 57.3. Supplier. So it's pretty cool. So right there is where my program would say, open back up the bench. Let's go to 68. I'm just going to do one click like every 10 seconds or so, I think, if it has to, so it doesn't overshoot. And if
still moves towards 100. Another click. And then as long as it is within that range, it'll stop adjusting. Sealed, but yeah, now, dude, talking about bringing in outside air, dude. There was a school I went and met some guy at. Oop, close that back down a pinch. It's kind of weird how that kind of overshot. They were trying to bring 25% on a little 4-ton unit. And the engineers there, and he didn't have a relief on a damper. He was using just a fixed, like, open, just a slide open, fresh air opening on the side of a package unit. No relief, no economizer damper, nothing. And then he says, we're only getting 22% on the test and balance. We need 25%. And I try to say you're going to have to air balance it by either restricting the return a pinch, which is the suckiest way to do it, but will work because you'll create a pressure drop across the end of the return, in which will draw in more outside air. I go, but know this, I go, any amount of air you bring in is air you have to push out, which means it's leaking out of the building. So you guys got 22% with no relief, no exhaust. Come on, that's freaking a lot. 22% outside air. And dude, these guys were pencil pushing engineer dudes, 2 of them, standing on the roof and just not believing me and all mad at my answer. And that's what they did. Instead of like putting a relief damper in or, whatever, they just put a bigger fixed, like a second, like eyelet, or what do you call those little hood shaped things? You cut the hole and put them on the side of they cut a hole and put a second one in to get their 25% outside air. And I'm like, you know what's going to happen? I'll tell you what's going to happen. Summer's going to come in Arizona when it's 110, 115, and it's going to blow out freaking 70-degree supply, and it's not going to cool, and because it's mixing in that much outside air with your return air, and it ain't going to cool. And your maintenance guy's going to come up here and close it all the way, and you're going to have 0% for outside air, and nobody's going to catch it because only him's going to be looking at it, and your kids are not going to have anything. Fucker. Complaining that he wasn't getting 25%. Shit. How do you remove a wall? This was a black mystery on the Mitsubishi. How do you remove mini split from a wall? I don't know what you mean by that. Compressor is a nice, deep, loaded sound. Oh, you're not hearing this. You can't hear that compressor. You're hearing, not this one that's cycled off, that's a rotary. Not hearing this 3-phase unit. It's the 3-phase in my house, run off VFD. You're hearing the reciprocating bastard Goodman over here. Bah, bah. That's not me. That's a piece of shit Goodman. But I still haven't replaced it because, I put the money into it if it still works. So I do have one R22 unit over there, which doesn't mean jack fucking shit since they're, oh, sorry, man. When I get political, I start cussing. They're demonizing 410 for its global warming potential. Now it's not the ozone. Oh no, it's global warming potential now that they got you guys by the balls. So now 410 shot up 400% in cost in the last year or two, right? And then there's going to be refrigerant 32 and 454 coming out. So hope you guys are ready to carry more jugs. I'm sure hardly anybody's carrying 22 anymore. Hopefully, who knows? I hardly ever was using it, honestly. But now you're going to have 410. Maybe you have some drop-ins, whatever you guys have been charging old 22s with 407C or whatever. And now you're going to have to have 454 and 32, which is a, butane blend. So be careful putting the lighters by that. I hate these two-handed lighters. But lost my sparker for my torch, that's what I have to use. Bounce it back up a little bit. Get it back up towards 10. 56.5 supply air. Yeah, it's back at 10 degrees. So, anyway, this video is probably just dragging on at this point, but I'm going to go ahead and probably end it there, and I need to put away all this stuff. So, anyway, at least we tested and know that refrigerant concoction works. It's just about putting on my controller now. So I'm going to put a 24-volt controller in there. I'm going to pair these two relays together, and they're going to run the compressor. the pulse width modulation signal will ultimately be running the fan, and 109 degrees, 110, it will have that fan on high speed, and it'll have a thermistor on there. This is just voltage for 5 volts, so 12 volt to run the controller, steppers and everything. Drops down to 5 for the logic, LCD, and hopefully this whole thing will fit in there. It might fit on top in there underneath the lid, actually, too, but I'll have to take the top off to get to it, which is fine by me, actually. Might actually be a better spot for it. This thing's just cranking out heat, man. It's working. So I should enjoy that room for the first time this summer. And like I said, I'm going to come out here in a little bit later before I go to bed and turn it off. I just have this switch will turn everything off, and I'll probably have to, I don't know, I got to probably barricade the area for that freaking, we got a black lab mixed with a boxer, man. He's crazy. Still a puppy. So he will shred stuff. Not as bad as a husky, though. Damn those dogs. To hell. But anyway, I could see this getting trashed. I could just see this being chewed up. I could see him yipping if I left it plugged in and he got zapped. Actually, there's no high voltage on that part, but if he chewed on these, But this outlet, like I said, this outlet here, 120 volt outlet, nice outdoor outlet I put, that goes to my solar charger inverter in there. Let's drop this and count to go to 64. So this is running off of batteries, dudes. This is running off those lithium ion batteries in there. So my whole water heater heated, and the sun was pretty much down when I started this video. So basically that room is cooled from 100 degrees to in the 70s. And I heated my water heater off of those batteries. And there's probably enough batteries in there to do that again before it charges again tomorrow. So that is cool. Plus I have a little more privacy. But now, whenever I need to go do something, here's that little Bluetooth keypad. Look at that. I can move this thing. If I had the software open, the batteries, I took them out for my testos, but I'm able to move this and stuff with that. Oh yeah, it's actually comfortable in here finally. Yes. My computer went to sleep. But anyway, I just want to see what this was. It's running off the inverter. That's the rating. Oops. Oh, 50 volts. It's still, so we're in battery is that's the rating. So yeah, so it's a 48 volt system, 50 volts even. That unit, I found those batteries with more charge than that in the morning. There's my batteries up there. So this is it's definitely lowered it. But remember, these lithium 48's the nominal voltage, so that most of its capacity, I think, from what I understand, is from here down to like 46 or so. So I probably only touched the top end of those batteries. If I brought a 48 nominal series lithium batteries from 56 to 50, and it can run down to 44. So I'm probably in the bulk, I think, of where they see the capacity is. So this will probably drop slowly from here on. So I'll probably be out on it, in and out of this room for the next couple hours, and I'll kind of see what that does. So anyway, with that, guys, my refrigeration part of it is a success. I just got to finish all my controls. Let me just double check the any comments I didn't get to. I explained that compressor growl was the good one. At the rate they keep demonizing refrigerants, I'm reading the comment from Edward, in a few years they'll have to legalize flammables to have anything left. 454 and 32 are flammable, partially somewhat flammable. So at least you can find the leak with the flame. And what's the guy said, for the school, installing a damper in the bathrooms is not a bad idea since they want one-way airflow, and that's probably where the air was pushing out through those. 22% outside air in Arizona, where you have that much differential in temperature, 110 to 115 in July and August. When you're running it in the 70s inside, you can't, unless you have a seriously oversized unit, you cannot be bringing in 25% outside air. Dude, people have been doing 10 to 15% until recently, and at startup, and then guess what? Most of those dampers get closed. I was a guy that's conscious to go, all right, I'm going to adjust it to get a decent a split temperature, but I'm not going to close it because that's obviously there for a reason, indoor air quality. But
Joe maintenance guy or the other techs that don't care or comprehend that, or they're not to that level of looking at everything, right? They're just looking at the unit not working. Oh, here's why. And they're just going to clamp that down. And they're going to shut it. Unit's going to kick ass. Person's going to be happy inside. But now they have no air exchange, and it's a classroom of 20 kids. That's why everybody, seriously, if they want to do everything right in a classroom, they should put economizers with CO2 sensors on. That way, it's very minimum until the CO2 comes up when the classroom's full, and then it'll modulate and drop it. So down to 49.9 volts. So, anyway, yeah. So all this is running. All this in here is running off of solar. The batteries from solar. The only thing that's not right now is actually this. Where I have my printer hooked up. This one plug here. I have it plugged into where that's the outlet up there. It's for the doorbell. So, and the lights were flash when this thing had a pretty intense heater in there that pulses or whatever, and it would like do stuff. I was like, I don't need to have that printer on my emergency power. So it's an old laser printer, so it actually probably pulses 1,000 watts or something, or maybe more when it dries that paper. All right, video's over for real this time. So hey, don't forget to like and subscribe and share the videos and all that kind of stuff. So same Samsung. Oh, the one that's out there. Yeah, I have two Samsungs. This is a regular S21, I think, and then or S20 maybe, and then my one out there is an S21 Ultra. With that crazy 40 times zoom or whatever it is. So yeah, there's two kind of. So anyway, I'll catch you guys later. Late.